So I wanted to talk to you a little bit about molar mass. Some of you may remember this from Chemistry 1. And if you had this during the shutdown, you may not. We went through things kind of quickly. And if you had me in the fall of last year, you may not remember either. I think this was one of the last things we did. So you may have checked out by then. So just a quick refresher on molar mass. Won't take long. So molar mass is just the mass in grams of 1 mole of a substance. It's kind of what it sounds like. But a couple of things to keep in mind. It's equal to the atomic mass, or it could be the sum of the atomic masses if you have a compound or a molecule, but the unit is always in grams. So when we talk about the sum of the atomic masses, that means that we're going to have to go to the periodic table to find those. I can't quite get the whole thing on my screen. If you look back, there's a link to a periodic table in that section there at the beginning of Canvas. But you can find these online. Hopefully you can maybe print one out. It's just easier than having to toggle back and forth with lessons and your periodic table. But if you can see the example that they're giving you here, you've got 2 main numbers in each square on the periodic table. The first one's the atomic number, which is the number of protons. Your symbol, most of them have the names listed on there. And then this is the atomic weight or the atomic mass here at the bottom. This one calls it weight. I like mass better. And this one happens to be a whole number, but they won't always be. If you look at some of these here, maybe I can zoom in a little bit. Let's see if we can focus that a little bit better. Most of these atomic masses are fractional. And we talked about why that is. It has to do with, those being the average atomic mass. Very important. For us, it's fine if you want to round these numbers to 2 decimal places. For hydrogen, I would call that 1.01. That's just going to save you a little bit of time punching in numbers and calculating. But be sure that you round up when you need to round up because it will make a difference. And so again, those numbers are just there for you on the periodic table. Also keep in mind that sometimes the numbers on the periodic tables can be different from table to table because of that rounding and because of maybe a method of calculation. It's not a big deal. It's not going to really affect your calculations much at all. But if you run into that and you're off in your calculations by the last number that's rounded there, don't get too bent out of shape or worried about that. So as we just talked about, masses are listed on the periodic table. That's where you're going to find them. So what that means is, if I look at an element like iron, and iron, remember, is sort of that odd symbol, Fe, the atomic number, the symbol, and the atomic mass. So 1 atom of iron has a mass of about 56 atomic mass units. I didn't round that to 2 decimal places because when we're talking about 1 single atom, it's a little different to think about, but just rounding that up to 56. But if I have 1 mole of those atoms, in other words, 6.02 times 10 to the 23rd of those atoms, then that is 55.845 grams in mass. And like we talked about with the mole concept that we did, you just have to, work with huge numbers of these. So we're usually not going to worry about the mass of 1 atom. We're going to look at the group of atoms, which is the mole. If you have a compound like sodium chloride, NaCl, there's 1 of each in this one. I'm going to look at sodium on the periodic table. It's in that first column there. Find its numbers. I'm going to look at chlorine. It's over here in this next to last column. There are its numbers, so you can see them. And I'm just going to add those up to get the molar mass for sodium chloride. So 22.99 plus 35.45 gives me 58.44. So 1 formula unit, which is kind of like a molecule, but not exactly like a molecule. If you remember, we use that for ionic substances because they have that crystal lattice structure. It's not just 1 unit of it. It's about 58 atomic mass units. 1 mole of those formula units, though, would be 58.44 grams. So that's really the only difference. If you do have something like lithium sulfate, where you've got more than one of an element, you just multiply. So the formula for lithium sulfate is Li2SO4. If I look at lithium's block on the periodic table, it has a mass of 6.94. But I've got 2 of those in each formula unit of this. So that's really 13.8 units of mass. So I've just multiplied that by 2. I only have 1 sulfur, so I just bring that number down. It's times 1. I have 4 oxygens, so I multiply 15.999 by 4 to get this number, and then I just add those up to get 109.936. Now I'm going to pay attention to my significant figures. I know, your favorite thing. These have 2 decimal places, or they're precise to the hundredths place. This one is precise to the thousandths place. So when I look at my molar mass, I'm going to round to the least precise, and so I've got 2 decimal places here to match my least precise numbers. So again, 1 formula unit of lithium sulfate would be about 110 atomic mass units, but 1 mole of those formula units would be about 110 grams. I can be a little more precise with my formula unit there. So that's the difference between molar mass and atomic mass, and that's how you calculate molar masses. Hope that helped you out, and we'll do a little bit of practice with this one. See you next time.